Hello, Mr. Sutton here with the Pre-Cal Honors 2-4 Part 1 homework solutions on graphing polynomials in intercept form. To graph this polynomial, let's first find the zeros. So setting all this equal to 0 and zeroing out each factor, we've got x equals -5, -1, +2, and +7 for that last one. Let's put those on our graph now. So we've got -5 somewhere over here. -1's a little closer to the y-axis, and on the other side of the y-axis we've got dots for 2 and 7. Alright, next let's find the y-intercept. So if I plug 0 in for x, I'm essentially doing 4 times 5 times 1 times -2 times -7. So multiplying all that together, 4 times 5 is 20, times 1 is 20, times -2 is -40, times -7 gives us positive 280. So that's going to be somewhere up here. This is just a sketch. And now we need to figure out the end behavior. So we see here that if you just look at the x's, we basically have x times x times x times x. So that's x to the 4th power, so that's a positive x to an even power. So that's going to behave like an x squared. It's going to be an upwards opening parabola kind of shape, at least at the ends. Now in between, let's look at the root behavior. It looks like all of these factors are first power, so all of these are single roots, which means that we're going to cross through all of them. They're all going to behave like lines when they hit the x-axis. So now starting above the x-axis, because this is an upwards opening parabola sort of shape, so we're starting up here, we're going to cross, 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 and cross. To graph this polynomial, we start by finding the zeros, the x-intercepts. So zeroing out each factor, we've got 3 for this first one, and then x equals -4 for the other one. So let's graph those out. We've got -4 somewhere over here to the left, and 3 somewhere over here to the right. And I mean, I'm guessing 3 would be closer to the y-axis than -4, but whatever. Definitely not drawn to scale, as long as things are in the correct sides of the y-axis. All right, so now we need y-intercepts. If we plug 0 in for x, you basically have -3 cubed times 4. -3 cubed is -27 times 4, that's -108. And that's going to be somewhere down here. So now let's figure out the end behavior and the root behavior. So for end behavior, we have to look at the degree in the sign. Overall, you've basically got a positive here, and you have an x to the 3rd times an x. So that's an x to the 4th. In general, this is a positive x to an even number. So this is going to have the shape of an x squared sort of graph. It's going to look like a parabola opening up, at least on the ends. Now let's figure out what's going on in between. So the root behavior, it looks like, let's see here, 3 comes from a cubed here. So that's going to be flattening. And -4 comes from a single root, a single factor, so that's going to be crossing. So we've got crossing at -4 and flattening at 3. So now we're starting above the x-axis because we start high and end high with this parabola end behavior. So we're starting up here. We are just crossing through 4, going through the y-intercept, and then after we do that, we are going to flatten through 3, and it looks like we're ending high, just like this end behavior suggests. For this polynomial, let's begin by figuring out the x-intercepts, the zeros. Setting each of these factors equal to 0, this -x squared out in front gives us an x value of 0 for that intercept, and this x plus 5 gives us -5 for that one. So we've got -5 somewhere over here, and 0 is the origin. Definitely no wiggle room on where you put that one. Let's get the y-intercept now. So let's see, if we plug 0 in for x, we've got -0 squared times 5 basically, which comes out to 0, and that just confirms what we already knew. Since we have an x-intercept at 0, the origin, that also is the y-intercept of 0, but it's not bad to double check that one. Now for the end behavior, we have a -x squared times an x going on here. So that comes out to -x cubed, or in general, a -x to an odd power. So this behaves like a negative x, basically a line going down. So we're going to start above the x-axis and end below the x-axis. And in between for our roots, negative 5 comes from this single factor. So a single root is going to give us crossing behavior. And 0, the other one here, that comes from this negative x squared. That's a double root, so we're going to bounce at 0. So we're starting up here, crossing through negative 5, coming back and bouncing at 0. And we end below the x-axis, just like we said we would. For this polynomial, let's start the graphing process by finding the x-intercepts, the zeros. So setting each of these factors equal to 0, this x out in front gives us an x-intercept of 0. And then this x plus 1, that means negative 1 is an intercept. And for our last factor, we have x equals negative 9. So let's put those on our graph. We have negative 9 out here somewhere. Negative 1 is going to be closer to the y-axis. And totally not drawn to scale, it's just a sketch. And then we have 0, which is also the origin. Now for a y-intercepts, it looks like since your origin is an x-intercept, it's also going to be a y-intercept, and it's going to be the only y-intercept. But just to be on the safe side, let's plug in 0 for all the x's. So we've got 0 times 1 times 9, and that does indeed come out to 0. So 0 is our y-intercept. Now for the end behavior, we've got x times an x times an x, all positive. So this comes out to a positive x cubed. In general, this is a positive x to an odd power. So this is going to behave like the graph of y equals x. It's going to look like a line, upward sloping line, at least in terms of the end behavior. So this just means that on the left, we're going to be below the x-axis, and on the far right, we're going to be above the x-axis. Now what's happening in between, looking at all these roots, these factors are all single powers, so that means that all these roots, all these intercepts, these are all single roots and are all we're going to cross through all of them. So all roots, we're just crossing through them, just like a line. So now starting below the x-axis, we cross through negative 9, come back and cross through negative 1, come back and cross through 0, and we end above the x-axis, just as our end behavior suggests we should. To graph this polynomial, let's start with the roots, the x-intercepts. Getting each of these factors to equal 0, for this negative x squared, we see that x has a value of 0, and for this x minus 4 squared, x equals 4 is going to be that root. So let's put those on our graph. We have 0, the origin, and also 4 somewhere over here to the right of the y-axis. Now let's get the y-intercept. Now it looks like our y-intercept is going to be 0. If we're on the origin, we're intercepting both axes at that point. But just to plug in 0 for x and make sure, we would have negative 0 squared times negative 4 squared, which would all come out to 0. So now our end behavior, we've got a negative x squared times an x squared going on. So that's a negative x to the 4th, in general, a negative x to an even power. So this is going to behave like a negative x squared sort of shape, a negative parabola, upside down parabola. We're going to start below the x-axis and end below the x-axis in terms of end behavior. Now in terms of the roots, these are both going to be double roots. So that means we're going to be bouncing at both of them. They both had a power of 2 for the factors that gave them to us. So these are both bouncers. So now we're starting below the x-axis and bouncing at 0, coming back, bouncing at 4, and we end below the x-axis just like the end behavior says we should.